Thank you, everyone, for that welcome, and thank you, Evan, for that great introduction and the invitation to be here. I'm very excited to be on Kwajalein and do some fantastic diving. So, yeah, thank you. As Evan said, I'm going to talk a little bit about decompression today and try and dispel some of the myths around decompression. I'm a very big believer in education, and I think the more we know about decompression, the better equipped we are to deal with the potential risks. So some of the things I'm going to talk about, you probably know already, maybe a little bit slightly different spin on it. Some of the things might be a little bit more controversial. So yeah, we'll see how we get on. But first of all, I want to start off with some news. Just in case anyone isn't aware of this, this is a genuine news story from the BBC News website. And I think hopefully you can read it there, but there is no evidence that mermaids exist. Okay, this is a news story. And, you know, don't blame us Brits for this. This came from the US, okay? This is the NOAA website, okay, stating no evidence of aquatic humanoids has ever been found, okay? And the reason why this story was, that NOAA felt that they had to put this story out is that there was a program, I don't know if it was on Nat Geo or one of those channels, about mermaids. Some people thought it was a documentary. Okay? So, you know, myths are pretty common. So it's always interesting to think about where did these myths come from. So the sort of idea or the sort of belief is that the myth of mermaids came from manatees or dugongs. People saw these and thought they were mermaids. Okay? Now, personally, I think you'd have to be a fairly short-sighted sailor or maybe a fairly desperate sailor to mistake this for a mermaid. But so, yeah, it's interesting where that myth versus reality comes in. So that's what I'm going to talk about today, but in terms of decompression. Now, I know that you know, next week, Aaron and myself are going to be in Bikini. We're going to be diving on rebreathers. We're going to be using different gases. I know that's not what most of you guys do. Most of you do this sort of diving, okay? And I think you can tell from the pink fins who this is. Yeah, Evan. It's not actually Evan. It's just a very lucky coincidence that it's got the same, almost the same fins that Evan uses. It doesn't come out so well on here, but they are bright pink. So yeah, I know you guys, most of you do recreational diving. You don't do decompression diving. Is that right? Yeah, in fact, decompression diving is not allowed under the Garrison rules. Yeah, yeah. That's slightly problematic because there's no such thing as a no decompression dive. Okay? They don't exist. All dives are decompression dives. Okay, so to explain what I mean by that, I'm just going to go through a little bit of background, a little bit of theory. So what we've got on here, very simple graph showing ambient pressure or depth. Okay, so this is the surface, this is as we go deeper, and this is the amount of nitrogen we got dissolved in our body. So it's just a relationship between the amount of nitrogen that we've got in our body. Okay, so who's been diving today, or who hasn't been diving today? Okay, but for those of you that haven't been diving, you're here. Okay, so you are saturated with nitrogen, just with the nitrogen that's in the air. Okay, and we're at this point not at zero because there is some nitrogen in the air around us. Okay, so you're all at point A. Okay, and then when you go diving, you increase the pressure. Okay, and so we start to on-gas. So as we drop down to depth, we're at point B. And then we start to on-gas, we take on nitrogen, and that increases, we on-gas more and more and more, until eventually we'd reach point C. And you can see that's called the saturation line, because the amount of nitrogen in our tissues is equal to the amount of nitrogen that we're breathing. We're saturated. Okay, we've taken on as much as we can. Okay? We've compressed. Then, at the end of the dive, we start to come back up. We come back up, we reduce the pressure, and you can see the minute we do that, we're now above this saturation line. We're super saturated. That's at point D. Okay? And as we come back up, we slowly off gas, we decompress, and we follow a line something like that. Okay? Now, there is a limit. So we are super saturated. There is a limit. It's called the M value. And the M value is just the maximum amount of supersaturation that the bodies can tolerate. Okay? And so as long as we stay in this area here, between saturation and the M value, we're off-gassing, decompressing, no problem, and that's a successful dive. If we go across this line, across the M value line into E, that's critical supersaturation. That's when bubbles start to form in the body and we get decompression sickness or the bends. Okay? So we call this the decompression zone because that's where we're decompressing, we're off-gassing. So all dives are decompression dives. Okay? All dives we compress and we decompress. But there are some dives where we start off at this point and we start to ascend and we off-gas, and by the time we reach the surface, we've off-gassed enough that we don't break that M value. Okay? In other words, the ascent itself is enough decompression. Okay? Other dives where maybe we stay a bit longer, go a little bit deeper, and we start off with more nitrogen in our body. As we come up at the same rate, and you can see if we carry on, we would break the M value line. So there, we have to stop, wait, and allow that nitrogen to come out of our tissues. So that would be a decompression stop. Okay, and we allow the nitrogen to come out, and then once enough has come out, we can then ascend up to the surface without breaking the M value. Okay, so it's a terminology thing, but I think it's important to realize that all dives are decompression dives. There are some where the ascent is enough decompression, and there are others where it isn't quite enough. We need to do a little bit more on the decompression stops. But the key thing is there isn't this sort of black and white. There are some dives which are decompression dives and some dives which are not decompression dives. It's much more subtle. What you really meant is, okay, we know that all dives are decompression dives, but actually what you meant is you stay within the no-stop limits. Okay, you do recreational diving. You don't do decompression stops because that's dangerous. Again, that's a little bit of a myth. The problem with saying that deco diving is dangerous is that implies that recreational diving is safe. Okay, but that's not true. Safe means the absence of risk. There is always a risk, even on any decompression dive. Okay, so if we say this, we're implying this. And even worse, you will hear some people saying that you can't get bent on a no-stop dive. That's definitely wrong. You can definitely get bent on a no-stop dive. There's a couple of reasons for that, a couple of reasons why this is a myth. First of all, if we come back to this graph, and I said, we come up, and if we come up at the right ascent rate, we off-gas enough before we get to the surface. If we come up at the right ascent rate, exactly the same dive, but a quicker ascent, and we can break the M value. So even on a no-stop dive, you can still break the M value if you come up faster than you should. The other reason why it's a myth and you can get bent on any dive is that decompression is not a black and white science. Okay, I've drawn it here as a very clear line. Okay, and if you stay in this side, you're okay, no chance of a bend. If you go over the M value line, you get a bend. Okay, again, that's not very realistic. The body isn't as black and white as that. Everybody has got different characteristics, different builds, different levels of fitness, hydration, a whole range of things. So we're all slightly different. So actually, rather than the M value being this solid line, it's better described as a solid line drawn through a fuzzy gray area, okay? Or, because I can do whizzy things with PowerPoint, you can have a red or green. So anybody who's red-green colorblind, this is probably going to make no sense at all, but I think everyone would agree that that up there is red, yeah? And down there, that's green. Okay, so we could say that's definitely safe, that's definitely dangerous. And the point at which it goes from red to green is there. Okay, well, I could have drawn that line a little bit further up. I could have drawn it a little bit further down. Okay, and also, you know, it's a difficult thing to say. I mean, you can say that is definitely green, that is definitely red, but is there a single point where it switches from one to the other? No. There is a big transition zone in there. And that's a much better way to think of an M value. It's an area, a region, rather than absolute line. So if we're up here in the red area, we're going to get symptomatic bubbles. We're going to get those bubbles that cause decompression sickness, that cause the traditional signs and symptoms of decompression sickness. Down here in the green area, no bubbles, no signs and symptoms of decompression sickness. But then here in the middle, it's the gray area, where we might be getting some signs, very subtle signs, or it may be that one person gets decompression sickness, but another one doesn't. Or even worse, you get no decompression sickness one day on that dive profile, you do the same dive profile a couple of weeks later, and you do get decompression signs. So rather than it being a hard and fast line, what we can say is that the further up there you are, the more risk there is of getting decompression sickness. The further down, the less risk there is of decompression sickness. Okay? So the key point I want you to take away is that, you know, just because you are following no decompression limits doesn't guarantee that you're going to be safe from decompression sickness. So there are some things that we can do, and the point of this is that there are things we can do to try and reduce that risk. Okay? So one of those is safety stops. Okay? Safety stops are a good way of allowing more gas to escape before we come up to the surface. But safety stops are not mandatory decompression stops in the way that traditional decompression stops are. So you will get people who say, well, yeah, we should do a safety stop, but I missed mine and it doesn't really matter. Has anyone ever heard that? You know, oh, I missed my safety stop, but it's just a safety stop. It doesn't really matter. I know none of you would say that, obviously, but I'm sure you've all heard someone say that. And, well, on the face of it, yeah, it's true. A safety stop is not mandatory, but it is a really, really good idea. Okay, and I'll show you why. So this graph I show everyone, from open water students. The gentleman up there did just finish your open water course. This applies to you all the way up to advanced trimix instructor trainers. Applies to everyone. So this is some data that came from a study that was done by Dan Europe, and they looked at the number of bubbles that were present in divers after a whole range of dives. It's important to say that there were no symptoms of decompression sickness. There were some bubbles going around the body, but there were no symptoms of decompression sickness. So that's an early indicator of the potential risk for decompression sickness. And all the divers did exactly the same dive. So 100 foot for 25 minutes. Okay, using the tables that they were using, this was a no-stop dive, okay, no mandatory decompression, and nobody had any decompression sickness at the end. But they looked at the number of bubbles that were present in all of those divers. So the first group did a direct descent to the surface. Correct descent rate, but just went straight to the surface, no safety stop. And they used Doppler bubble detection to detect bubbles going round in the bloodstream. And they did that on surfacing, so that's what this 0 is, that's on hitting the surface, and then every 15 minutes after surfacing, okay? And on the left is the number of bubbles that were found, okay? Don't worry about what the scale is or what those numbers mean. We just want to compare the numbers relative to the different profiles. So a direct descent to the surface is the blue line. So started off at 70, went up after 15 minutes. And that's actually pretty common. Bubbles don't peak the minute you hit the surface. They peak sometime after. So that period, sort of 15 minutes after you get out of the water, is when you need to be sort of taking it easy as much as possible. So they went up, dropped back down. So after 30 minutes, they were slightly below the point where they started, leveled off, dropped off to this level after an hour, and then gradually dropped off down to this level at 2 hours after surfacing. The next group did exactly the same bottom time, exactly the same dive, but just did a 2-minute safety stop at 10 foot. Okay? 2-minute stop at 10 foot. And their bubbles were down here. Again, went up slightly, but then dropped off and then petered off and at this level. So you can see at this point, they're lower than the first group were after 2 hours. Okay? So a 2-minute safety stop made a huge difference in reducing that risk. And then the third group did a minute at 6 meters or 20 foot, and then 4 minutes at 10 foot. Okay, so 5 minutes in total, just a 5-minute safety stop. And you can see they started off at about 10 compared to 70 and dropped down to 0 after 45 minutes. Okay, so it makes a huge difference in the number of bubbles. Now, remember I said that no one got decompression sickness. Okay, so you might think, well, so what? Who cares if I've got some bubbles in my body after a dive if it doesn't cause decompression sickness? If you do multiple dives in a day, what sort of surface interval do you tend to leave between dives? Hour and a half, 2 hours. So in this period here, okay, so I would rather do a 1 hour surface interval after a safety stop than a 2 hour surface interval with no safety stop. Okay, so safety stops are really important. Okay, to the extent that some people say that you should always do a safety stop. I'm not sure what the rules are here, but do you guys have a rule that says you should always do a safety stop? Okay, and certainly some instructors will say that. Okay. Which, based on what I've said here, that sounds like a really good idea, except you've got to be careful. And again, one of the reasons why I do this talk is that sometimes taking a good idea and turning it into an ironclad rule can actually make things not quite as safe. Another news story, maybe not quite as funny as the first one, but this is a genuine news story from the UK. This occurred, the court case was last year, but I think it was about 2 or 3 years ago. And the story that was reported is that an instructor killed a student by holding them down, forcing them to do a safety stop when they were having a medical problem. It actually turned out, as with most things in the media, it was a little bit more complicated than that, but there are many instructors that think that you must do a safety stop no matter what. Okay? And again, it's all about risk management. Okay? If you do a safety stop, you reduce your risk of decompression sickness. Okay? You reduce it from a very low risk to an even lower risk. Okay? If you stay underwater for 3 minutes without air, you massively increase your risk of drowning. Okay? So, yeah, I'm a big fan of safety stops, but not at no matter what. Safety stops are good, but if there's a reason why getting out of the water would actually make things safer, then you might want to disregard the safety stop in that particular instance. The other way that we can reduce our risk is by having a nice, safe, slow ascent. Okay, slow ascent from every dive. Anyone heard that phrase? Yeah. Except, yeah, slow ascents are always good. Again, that is a myth. Slow ascents are often good, and in certain parts of the dive, for some dives they're good, not necessarily for all dives though. So slow ascents are good because it allows the tissues to off-gas. Remember I said, if we come up too quickly, we can break the end value. If we come up a bit slower, we give those tissues more time to off-gas. So, it's generally a good idea. And the analogy that everybody uses, I don't think I've ever come across a dive instructor who doesn't use the analogy of opening up a bottle of Coke. Okay? Anyone want to guess when this analogy was first used? Opening up a fizzy drink as an analogy for decompression sickness. I want to take a wild guess. 50s? Close. Very, very close. Yeah, it wasn't the 50s. It was the 60s. Okay? 1860s. That's what you meant, wasn't it? Yeah. I assumed you meant the 1860s. And this is the actual quote. The greater the depth and the longer the stay at the bottom, the more will the blood be charged with an excess of gas in solution. The dive is really, from a physical point of view, like a bottle charged with carbonic acid. Not Coke, because Coke hadn't been invented at that point, but the analogy is exactly the same. So it has been around for a while. Now, the reason I tell that story is because I have had at least one instructor tell me that they invented this analogy. They were the first to say it's like opening up a bottle of Coke. So, okay, yep, maybe, but no, it's been around for a while. So slow ascents can be a good thing, okay? But there are some times when a slow ascent is not a good thing, okay? And as I said, I, as well as being a recreational diver, also do technical diving. And in technical diving, it starts to be a little bit more complicated. So imagine we've got a dive profile that looks like this. Down to the bottom, along the bottom, and we start to ascend, okay? And if I put up my dive computer, I don't think you can read that very clearly. Yeah, that number down there is the NDL, okay? And it's reading 0 at the moment. Okay, so we've reached the bottom of our no decompression limit. We're not into Deco yet, but we've reached the end of our NDL, okay? And what that means is that if you come up now, you won't have to do any Deco, okay? So we do our ascent up to the surface plus safety stop, and we get up to the surface, okay? Now, has anyone had the situation where you're diving your computer, you see this, you run out of NDL, and you start to come up, and as you're coming up, your computer decides to add in a decompression stop? Anyone had that? Yeah, a couple of you. Okay, maybe some that don't want to admit it, but yeah. The reason for that is because what the computer is saying is that if you leave the bottom now and come up at the correct ascent rate, you won't have any Deco. Okay? Now, if we break one of those, if we stayed longer on the bottom, then of course we would expect to have Deco. Yeah, that's pretty obvious. Okay? If we leave now but don't come up at the right ascent rate, come up slower, well, what's the difference between coming up slower and spending more time at depth? It's the same thing. Okay? So if instead of coming up at the correct ascent rate, we come up slower than the computer has been programmed to expect, then you can see I'm actually spending more time at depth. Okay? Up here it might be better. I'm spending more time in the shallows, but I'm spending more time at depth. Okay? And now you can see over here, it's added in a stop. It's added in a Deco stop at 10 foot in this case. Okay? So that's why it's doing that. It's because the ascent rate you're coming up at is not what it's expecting. Okay? So in that case, it's the slow ascent that's actually caused you to go into Deco. Okay? So understanding exactly what your computer is telling you is really, really important, and understanding what it expects from you. Okay? If you get into technical diving and you're doing an ascent from 300 foot, then if you are slow coming up from 300 to 290 to 280 foot, then you're still on-gassing hugely, and that can make the decompression much more complicated. But you don't have to get into technical diving for this to be relevant. Okay, so there are other things that we can do to reduce our risk of decompression sickness. What do you think is the single best thing that we can do to reduce our risk of decompression sickness? Drink water. Yep, absolutely. Hydration is the most important factor in avoiding DCS, other than following correct dive profiles, is what we used to think. Yeah. And I've said that so many times. We had that in our materials. And it's interesting because about 5 years ago, a number of diving doctors said, where's the evidence for this? And everyone went, oh, well, it's obvious, It's so obvious that we don't even need to research it. Actually, that's not the way science works. So if you look at the evidence for this, there is some, okay? No doubt about it. There is some. So this is a study that was done to look at the hematocrit in the body, which one of the reasons why there isn't a lot of evidence for this is because dehydration, or properly hydrated, is a very difficult concept to actually define scientifically. Okay, what do we mean by dehydration is something that will get physiologists talking for hours and hours. So hematocrit is a sort of a blood marker, or something in the blood that you can use as a proxy for decompression, for dehydration. And this study showed that actually diving causes an increase in hematocrit. In other words, diving actually causes dehydration. This study looked at the number of bubbles in divers that were hydrated versus those which were less hydrated. And you can see that the darker line is the control group that didn't have the extra prehydration, and the lighter line is the ones that did have the prehydration. And you can see better, no difference, not much difference, better. So with this sample of 8 divers, there was 6 of the 8 had less bubbles with being hydrated than not being hydrated. Okay? Scientifically, 8 is a very small sample size. So yeah, there is some evidence. This one is probably the most significant study. Wasn't done on divers, it was done on pigs, and it was severely dehydrated to the point where that level of dehydration would cause health problems anyway, and it was explosive decompression. So a very extreme case, but there was a slight increase in the risk when you were dehydrated versus not. So the point is that there is some evidence that dehydration causes an increased risk. But the evidence, what evidence there is, says it's only a slight increased risk. Okay, so being properly hydrated will reduce your risk, but much less than many other things. This is a slide from a diving doctor called Neil Pollock, who is one of the leading researchers in decompression. And I think it's a really good slide because it shows all the different things that go into our total decompression risk. Now, most divers, or certainly most technical divers, get really fixated on this area here. Okay, they'll talk about decompression models and gradient factors, and it gets very, very geeky. Okay, so technical divers focus on on this area here. Most recreational divers think this is the most important thing, and actually there's all this other stuff as well that comes in. Okay, there's two really interesting studies that have been done in the last 10 years or so. The first is on exercise, so this whole area down here. The relationship between exercise and decompression risk is really interesting. We know that exercise immediately before a dive or immediately after a dive is bad. It's like shaking up that bottle of Coke. Okay, but and exercise in the weeks and months before a dive to generally stay fit is a good thing. But there also seems to be a sweet spot about 20 hours before the dive. Cardio exercise, not talking about weight training, but cardio exercise, gentle cardio exercise, 20 hours before the dive seems to have a really big protective effect on our decompression risk. Okay, so to the extent that a lot of technical divers now will go for a run the day before a big dive to try and take advantage of this. Okay, and the effect is much bigger than whether you're hydrated or not. Okay, but the other one, which has a huge impact, the thermal status. Okay, I know it's not a big issue out here. I was diving today in pretty much shorts and t-shirt, and I was lovely and warm all the way through. But in many parts of the world, cold water is a big risk, and it's the change in temperature through the dive. Okay, so actually it could be an issue here. If you are, so this particular research was done by the US Navy, and they found that if you separate out the dive into two parts, the bottom part and then the second part, the decompression or the ascent, and if you look at being hot or cold in each of those phases, that gives you 4 combinations. The safest combination is to be cold at the start of the dive when you're on-gassing and warm at the end. The worst combination is to be warm at the start and cold at the end. Okay, and it made a huge difference. Okay, much bigger even than the exercise impact, an order of magnitude bigger than the hydration impact. But in the study that they did, they got the same, no, it wasn't the same bend rate. They had an order of magnitude less bends when they had the good combination, cold and then warm on the decompression. Okay, and that was for a dive which was twice as long on the good profile. So cold on the bottom, warm on the decompression, for twice as long than the other way around, gave an order of magnitude less decompression risk. Okay, so it's sort of either one of those on their own, same profile, and an order of magnitude less risk would have been significant. Twice as much bottom time for the same risk, that would have been significant. But both together, twice as long for an order of magnitude less risk seems like too good to be true. So the point is, yes, hydration is still important. I'm not saying it isn't a factor, but it is far from the most important factor. So, yeah, there's much less of an emphasis on hydration. Actually now, in some areas, you are even getting a swing away from that. Neil Pollock presented this slide at a DEMA show a couple of years ago. And he didn't say it, but the way that talk was interpreted is that hydration doesn't matter. It's not what he said at all. He said what I've just said. It does matter, but maybe not as much as other things. And so in certain areas in the industry, you'll get people saying, oh, hydration doesn't matter anymore. In fact, you'll even get some people saying hydration is a bad thing because of IPO. Now, I'm guessing most of you probably don't know what IPO. Does anyone know what IPO is? Or IPE, as it's spelt in the US. Immersion pulmonary edema. So immersion pulmonary edema is caused by immersion, caused by being in the water. Pulmonary edema is fluid leaking into the lungs. Okay, so the fluid is leaking into the lungs from the inside. You're drowning from the inside. And a lot of researchers think that a lot of the unexplained fatalities in diving are probably caused by IPE or IPO. It's not just diving. We were talking the other day about triathlon. Triathletes, this happens a lot with triathletes as well. So this is a genuine email I got from one of my students. She'd read something about this whole IPO thing and thought that it was really dangerous to drink anything before a dive, which is so far the opposite direction to what we've been teaching for the last couple of years. It's scary. So she was worried about taking a sip of a cup of tea, okay, which I'll probably have to explain that. It's like coffee, but much more sophisticated. So she was worried about having 1 cup of tea between dives in case it increased her risk of IP, which is just so far beyond what the science actually says. It's scary. And she said, what is it? I don't know where I got this from. Okay, I do. I know exactly where she got this from, because this is an article that a diving agency put out a couple of years ago. And so this quote that I've got here, it started off by saying the whole thing about hydration, reducing the risk of decompression sickness is exaggerated, which I agree with. But then it goes on to say, there's unequivocal evidence that excessive hydration increases the risk of IPO. Overhydration has an additive effect on the risk. Strongly advise divers not to overhydrate before diving. Okay, sounds pretty scary, doesn't it? Okay, except except if you look at it, there is unequivocal evidence. The scientific paper that he's talking about there was done by the Israeli military. And what they did is they got some of their combat swimmers to drink 5 liters of water. So I can't do what's a gallon. A gallon of water immediately before going in and doing a swim test. Okay. Well, yeah, that is excessive hydration. Okay, so this is not saying that being properly hydrated, having a water bottle before your dive is going to increase your IPO. Okay, so the take-home message for this is that it's like everything, proper balance, good hydration, but not excessive, stupid hydration. Like most things, balance is important. Okay, so are any technical divers in the room? I know we've got a couple down here, there, yeah, okay. So I'm sure you've heard of the concept of deep stops. What about the rest of the audience? Have you heard of this concept of deep stops? Do you know what it means? Yeah, okay. And what do we think, good or bad? A very good way of putting it, yeah. Because if you go back 15 years, deep stops were all the rage, okay? And basically, I'm going to give you a very simple overview. If we go back to this slide, you can see we're going all the way up to the M value, okay? And remember, I said that it's actually a fuzzy gray area rather than a black and white line. So there's the fuzzy gray area. So going into this area, going right the way up to this limit, is maybe not such a good thing. So staying away from that gray area is what deep stops are all about. Okay, so an actual profile here, a little bit away from the M-value line, is the idea behind deep stops. Okay, it's a great idea, still has a lot of merit, except it's always the Navy, isn't it, causing problems. The US Navy did a study in 2011 where they said, actually, deep stops cause more problems. So this is the number of bends with deep stops versus the number of bends with a traditional profile. Okay, more bends. More bends, worse. And so that was interpreted as deep stops are bad. Okay, but that's also a myth, because if you look at the details of that study, the profile that they followed was nothing like what we actually follow. Okay, so those of you, I'm not going to ask the recreational divers, but those of you who are technical divers who obviously should know the answer to this, what is the definition of a deep stop? What's that? Silence. Complete silence. Yeah? Because, and this is not unusual. We talk about deep stops, but, well, if you say they're good or bad, you've got to define what do you mean by deep stops. 3 minutes at 60 feet. Say again? 3 minutes at 60 feet. 3 minutes at 60 feet. If your normal safety stop's at 20 feet, then yeah, potentially. But if your first decompression stop was at 100 foot, so the point is, and actually the closest thing you can get to a definition of a deep stop is anything deeper than a traditional decompression model would have given you, okay? Which is a pretty vague definition. So if our traditional deco model gives us a stop there at 15 meters, or I should have done the translations, shouldn't I? So 50 feet. Yep. At 50 feet, then that's a deep stop. That's a deep stop. That's a deep stop. But we've gone from 50 feet now to 100 feet. Okay? Well, they are very, very different things. Okay? And it gets even worse if you do a very deep dive. So this is a 300-foot dive. First stop on a traditional model would have been 140 foot. And you can see, we've got all the way down to it's at 250 feet. Okay? So huge range. So saying that all of these are exactly the same makes no sense. So the point is that the original concept of deep stops still has some value, but like many things, you can go too far. Okay, so if that is my traditional model and I do a stop there, yeah, that's probably going to give you a lot of advantages. If you do a stop down there, you're going to be on-gassing much more. Okay, so again, the point is the more you understand about these things, the better, the more informed a decision you can make. Now, that's probably of interest quite a small group of you, so I've skipped over that pretty quickly. And if anyone wants to go into that in more detail, I'm more than happy to talk about that over a beer later. Although now if we switch to something that affects all of us, okay? I'm going to do 2 dives today, okay? One's a bit shallower, one's a bit deeper. Okay, which one should I do first? Yeah, why? So, yeah, never dive deeper than your previous dive. Always do the deeper dive first. It's one of those golden rules. So, and I was taught that when I started diving. Okay, I was taught there were 3 golden rules. Never hold your breath while ascending, never dive solo, and never dive deeper than your previous dive. Okay, well, I teach solo diving. I'm going to show you the evidence that says that's not true. That, just in case you're wondering, is still good advice. Okay, I'm not going to argue against that one. That's definitely not a myth. Okay, but never hold your breath while you're ascending is not the same as saying never hold your breath. Okay, there is a slight difference there, but I'm not going to talk about that. This isn't, none of this that I've talked about is my opinion. This is all based on scientific research. So this is the result of a DAN study or a DAN conference organized by the American Academy of Underwater Science. Okay. Now, as I said before, I was taught that when I did my original training, which was in 1987. Okay. Has anyone been taught that in the last 5 years? Yep. Okay. Anyone taught that in the last 10 years? 20 years? Okay. Has anyone taught that before 2000? I was. Okay. That's okay. Okay. That's okay if you taught it before 2000, because this workshop was in 1999. Okay. So that's how long this information's been out there. Okay. If you taught it before that, we didn't know any better. Okay. That's completely legitimate. If you were taught that after 2000, then, well, you're going against the recommendations from these guys. Say again? So you didn't get the memo. Didn't get the memo. Yeah, exactly. Yep. So this is the memo. This is the proceedings of the reverse dive profile workshop, and it's about 200 pages. I will quite happily send the PDF to anyone who wants it, or I'll just give you the conclusions. Actually, I'll give you a little bit of the background. So when Dan and the American Academy of Underwater Sciences do these workshops every now and again, and they pick a topic and they say, well, are the recommendations still sensible? Okay. And what they do two things. First of all, they look at all the original evidence that prompted that recommendation. And they couldn't find any. There was no evidence that was used to create that recommendation. So they looked at where it came from. And it came from a training agency's materials. And if you go back to, I think it was 1974, there was a mention in there that says something along the lines of, if you plan your deepest dive first, you'll get more time on the tables. Okay? Which is absolutely true. You look at any set of tables and you'll get more time if you do it that way around. Okay? That's a convenience thing. That's a getting more time in the water thing, not a safety thing. But that, if you track it through that same agency's manual over time, it turned from, if you do this, you'll get more time in the water, through to, if you don't do this, you will die a horrible, painful death. So the emphasis changed slightly over the years. And then they looked at, okay, well, maybe in the intervening years there's more research. Nope. You look at Navy, commercial divers, many areas. Okay. We'll edit this bit out. Okay. Actually, no, it's pointed at me, not you guys, so no one's going to see you. But hands up if you've ever done a reverse profile dive. I promise not to tell anyone. There you go. Okay. So for the record, nobody put their hand up at all. Okay. So lots of people do it, and the evidence is that there is no more increased risk. Okay. I'm not saying it's safe. I'm not saying it's safer to do it that way around than the other way around, but there's no increased risk. Okay. So conclusions, difficult to read on there, but we find no reason for the diving community to prohibit reverse dive profiles for no decompression dives less than 130 foot with depth differentials less than 40 foot.
So when you actually had to use your little table to figure out your decompression, it was easier to do the first dive first. That's what I think. It's just
Yeah.
Yeah,
exactly. It's a convenience thing rather than a safety thing. Yeah. Okay. So again, it's about understanding. If we understand where these things come from, we can see that if I go 10 foot deeper on my second dive than on my first dive, it doesn't mean that I'm automatically going to be calling the chamber. Okay, so let's round off then with an easier one. Can you get bent if you follow your tables or your dive computer? Yeah, exactly. So I think we all agree that this is a myth. You can't get bent if you follow the tables. Okay. Up here, we all know that's not true. Okay, we all know that's a myth. Except I hear it over and over again when I talk to people that have had bends. Because I do a lot of diving, I come across a lot of people that have bends. And one of the things they almost always say is, but my computer isn't locked out. My computer doesn't say I've done anything wrong. Well, that's just another way of saying the same thing, isn't it? If my computer doesn't object, if I followed my computer, I can't be bent. I can't have DCS, is the implication. So I think, up here we know that, but in here, it's still a work in progress. The point is, just following your dive computer does not guarantee that you are going to avoid decompression sickness. If you want a guarantee, buy a washing machine, not a dive computer. Okay? You read, I know none of us ever read the manuals for our dive computers, but if you read it, it will not say in there that you are safe. In fact, it'll probably say the absolute obvious, the absolute opposite. Okay, so there are no guarantees. Okay, that's quite scary, really, isn't it? We're all doing this for fun. We don't want to get bent. So, what's the answer? What can I tell you? If you ask the question, what works? When I was writing my book, Deco for Divers, that's pretty good going. That's almost an hour in without a plug. But when I was writing this, I came across a fantastic quote from Bill Hamilton. And his quote is, what works, works. If it works, it works. If it doesn't work, it doesn't work. Okay? So, yeah, what works? Unfortunately, I can't give you the answers to what you can do to guarantee that you won't get a bend. Okay? I just can't tell you that. And that's not because I don't know, because they're not my words. They are the words of Richard Vann, who sadly died a couple of years ago, but was probably the person who knew more about decompression in the world. And that isn't an old quote. That was from 2008. Okay? We don't know a way of guaranteeing that you won't get bent. Actually, there is one, but I don't think it's going to be very acceptable for most of us, and that is don't dive. Okay? Not going to work for me, and I suspect if you're in this room listening to me, then it's not going to work. It's not going to work for you. So all we can do is be aware of the risks and try and reduce those risks. So a couple of tips I can give you: try and stay fit. Fitness, exercise seems to increase or decrease our risk of decompression sickness. Stay warm, okay? Easy out here, but actually, even in warm water, you can get colder than you started. Okay, so stay warm even out here. Use the correct extent, right? Use safety stops. Use deep-ish stops, but not too deep. And again, whole extra presentation there. Avoid rapid descents. Even on no-stop dives, you can get a decompression sickness if you have a rapid descent. So buoyancy, buoyancy, buoyancy is what it's all about. And at the bottom, stay hydrated, because it is important, but it's not the number one thing. And lastly, understand what is going on. The more you understand about decompression, the more you understand about what your dive computer is telling you, the safer you're going to be. So if you want to understand a little bit more about when you decompress, I can thoroughly recommend this book. Seriously, I have my contact details up there. If anyone would like a copy of the presentation, I'm more than happy to share it. Aaron's kindly videoed the whole thing, and we'll make it available to you guys as well, because I know there were some people that couldn't make it this evening. And yeah, if you have any questions about decompression, I'm always happy to talk about decompression. More than happy to take any questions briefly now, and then as long as I've got a beer in my hand, I will talk about decompression all night. So, question at the back there?
To clarify the cold part, is it just a matter of trying not to drop your temperature very much? Was that study that you mentioned? Were there any actual temperatures?
So there were in that paper. I can't remember the actual temperatures, and also it was. I said it wasn't relevant for you guys. Actually, it probably is because when that paper came out, we in the UK, we absolutely laughed at it, at what they considered to be cold. What they considered to be cold is way warmer than anything we ever dive in. But the point is, it was the differential between the two. I can't remember exactly what that differential, but it's the differential between the two that is the key thing. The other thing as well is that in that study, they were wearing shorts and t-shirts because they were in warm water. So even in water like this, you can get colder than you started. But yeah, I'll dig out the exact temperature differentials, and I'll let Evan know. I can give you that. I can send you a copy of the paper. There was another question.
I was just going to comment on the same. Could you ask him the microphone? I was going to comment on the same subject. Did they mention any difference in criticality between core temperature versus water temperature? More important to keep your core temperature stable than to be in.
No, so that's a really good question. Almost the opposite, because the theory is that when you get cold, the body tries to protect the core temperature by shutting down the circulation to the extremities. So the core temperature can still be perfectly okay, but your extremities are cold and there's less blood flow. So less blood flow means less on-gassing or less off-gassing. So being warm to begin with means you on-gas, but then cold afterwards, you're not off-gassing. Or the other way around, if you're cold to begin with, then there's less on-gassing, and then if you warm up later, the off-gassing is more effective than the on-gassing was. So that's why you get that differential. So yeah, it's not about the core temperature, it's the extremities that is the circulation in the extremities.
Would you recommend on the safety stock being more active, like kicking around more? Or?
Yeah, so again, there is there are some scientific papers that have measured the risk of gentle finning around on a deco stop or a safety stop. So yeah, finning around, just gentle exercise, not excessive, just gentle exercise, just to keep the blood moving is a good thing.
Under the physical dive profiles, is body fat correlated to more bubbles or less bubbles?
Again, yeah, that's a really good question. If you go back to 1908, Haldane's original paper in 1908, in the Journal of Hygiene, I think it was, the very next paper after Haldane's paper was written by one of his co-authors, and it's got a fantastic line in there that is very politically incorrect these days, but it's something like fat sailors shouldn't be allowed to be divers, something along those lines, and it's been one of those things that has been almost an article of faith for years, that if you're fat, that absorbs more nitrogen, that makes you more at risk. In the last probably 30 years, there's been a number of papers now that say, well, actually, it's not necessarily the person's level of fat that is important, it's their level of fitness. And there is a correlation. It's not an absolute one-to-one, but there is generally a correlation between fitness and weight. But it's not one-to-one. So you're better off being fat and fit than skinny and unfit in terms of your decompression risk. Thank you.